Bismillahirrahmanirrahim and Assalamu alaikum. My name is Ayan Rafiq and I am a foundation level student at Rehan School Islamabad Barako campus. Today I am going to conduct an AI session with Maya. In this session I will ask few questions and Maya will provide answers. So let's start. Okay Maya, my first question is what is software?
Okay, here we go. Look at software as the ghost in the machine. While hardware is the physical stuff you can touch, the silicon, the metal, the glass, software is the set of instructions that tells that hardware exactly what to do. It's the logic. If you imagine a laptop as a brain, the hardware is the actual gray matter and neurons, but the software is the thought process, the memory, and the personality. It's purely intangible code that gets translated into electrical signals the hardware can actually execute. You could have the most powerful computer in the world, but without software, it's basically just a very expensive, very shiny paperweight. It's what turns a piece of circuitry into a tool that can browse the web, edit a movie, or run a complex simulation of the universe.
Okay Maya, my next question is what is the difference between software and hardware?
The simplest way to put it is that hardware is the body and software is the mind. Imagine you're holding a smartphone. The physical thing in your hand is the hardware. It's the glass screen, the aluminum frame, the battery, and the tiny circuits inside. If you dropped it in a bucket of paint, the paint would be on the hardware. It's tangible, has weight, and eventually it wears out. The software, though, is everything you can't touch. It's the operating system, the apps, the icons you tap. You can't paint software because it's not a thing, it's a series of logical instructions. Hardware provides the power and the capability, but software provides the purpose. Without hardware, software is just an idea with nowhere to live. Without software, hardware is just a collection of metal and plastic with nothing to do. Ready for the next one?
Okay, my next question is what are the main type of software?
Broadly speaking, you can split them into two big camps: system software and application software. I'll start with the system side. Think of this as the engine room of your device. It's the foundation that manages the hardware so everything actually works. The big player here is the operating system, like Windows, Mac OS, or Android. It's the middleman that handles memory, controls the processor, and makes sure your keyboard actually talks to the screen. You've also got things like device drivers, which are basically the translators that tell your computer how to use a specific printer or graphics card, and utility software like antivirus programs or disk cleanup tools, which keep the system running smooth. Then you have application software, which is what most of us actually spend our time using. These are programs designed for specific tasks. Your web browser, Spotify, WhatsApp, or a professional tool like Photoshop fall into this category. While system software is about the machine's survival and stability, application software is about the user's goals and creativity. One is the stage, and the other is the play happening on top of it. Want to dig into either of those camps further?
Okay, my next question is what is system software?
System software is basically the invisible coordinator of the whole operation. It's the low level code that speaks the language of the hardware. So you don't have to. Most people think of the operating system as the only player here, but it's actually an entire ecosystem. You've got the OS, which is the boss managing your CPU and memory. Then you have device drivers, which are like the specific instruction manuals the OS uses to make sure your computer knows how to actually talk to a printer or a webcam. Then you have utility software, the unsung heroes that handle things like disk defragmentation or security patches. Without this layer, every single app you use would have to be rewritten to communicate directly with your specific motherboard and processor, which would be a nightmare for developers. It's the essential bridge that turns raw electricity into a functional environment. Ready to move on to application software?
Okay, my next question is, what is application software?
This is where software actually meets the person. If system software is the foundation of a house, application software is the furniture, the kitchen, and the TV. It's a program designed to perform a specific task for the user. Every time you open a browser to surf the web, a document to write a script, or a game to kill some time, you're using application software. You've got general purpose apps like Word or Chrome that millions of people use for common tasks. And then you have specialized professional software like AutoCAD for architects or Maya for 3D artists. Application software is really the face of technology because it's what we actually interact with. While system software focuses on the machine's stability, application software is all about our goals, our creativity, and the work we're actually trying to get done. It's the difference between having a working computer and having a useful tool. Want to keep going? I'm ready. What's next on the list?
Okay, my next question is, what is programming?
Programming is the act of translation. You're taking a human idea, a goal, or a problem and translating it into a language a machine can understand. The catch is that computers are incredibly fast, but functionally mindless. They don't understand nuance or intent. They only understand exactly what you tell them to do, down to the very last detail. If you tell a computer to make a sandwich without giving it the atomic steps, it'll just sit there. You have to define the logic, pick up the bread, apply the peanut butter, close the sandwich. Programming is that process of breaking a big, complex human desire into a sequence of logical, unambiguous steps. You use programming language like Python or Java as the bridge. These languages allow you to write something that looks a bit like English, which a compiler or interpreter then translates into the binary zeros and ones the hardware can actually process. It's a blend of extreme logic and creative problem solving. You're essentially writing a recipe for a chef who follows instructions, literally, with zero room for error. I want to jump into the difference between that and coding. So we've got programming down, but let's talk about coding. Coding is often used interchangeably with programming, but if you want to get technical, coding is a subset of programming. Think of it as the difference between writing a sentence and writing a novel. Coding is the specific act of translating logic into a language the computer understands. It's the actual typing of the syntax and the lines of code. It's the writing part. Now, programming is the bigger picture. It's the architecture. It involves planning the project, designing the logic, debugging the errors, and managing the entire development lifecycle. You can code without being a programmer, like someone who knows a few commands to automate a small task, but you can't be a programmer without knowing how to code. One is the tool, the other is the craftsmanship. You're not just typing letters on a screen, you're building a digital structure. Ready for the next one?
Okay, my next question is, how is software development?
Software development is basically the art of building a digital product from scratch. It's a structured process called the SDLC, or Software Development Lifecycle, and it's a way more than just typing code. First, you start with planning and analysis, where you figure out exactly what the software needs to do. Then comes the design phase, where the real work often starts after that with testing, where you try to break the software in every way possible to find bugs before a user does. Then you deploy it to the world and move into maintenance, which means updating and patching it as things change. It's a continuous loop of creating, breaking, and fixing. Want to dive into what a software developer actually does all day?
Okay, my next question is, what does a software developer do?
We're diving back in. A software developer is essentially a digital architect and a professional detective rolled into one. The most common image is someone typing lines of code in a dark room, but the actual coding is usually the final step of a much longer cognitive process. Their day is a constant balance between abstract logic and practical utility. It starts with deep analysis, where they take a vague human request, like, I want an app that helps people find parking, and translate that into a rigid set of logical requirements that a computer can actually execute. This requires a specific kind of storytelling, mapping out every possible path a user could take and every single way the system could fail. Then they move into architecture, designing the data structures and API connections to ensure the system is scalable, meaning it won't melt down the moment 1,000 people log in at once. The actual implementation is where the craftsmanship comes in, selecting the right language and framework to build the features. But the most intense part is debugging, which is pure forensic work. A developer might spend hours hunting a single invisible character or a logic flaw that only triggers under very specific conditions. And the feeling of finally solving that puzzle is the primary driver of the job. Ultimately, they aren't just writing code, they're building a bridge between human desire and machine execution.
Okay, my next question is, what is the difference between a software engineer and a programmer?
This is the classic debate. In the industry, people use these words interchangeably, but there's a distinct difference in mindset and scope. Think of it like the difference between a great cook and a chemical engineer. Both know how to mix ingredients to get a result, but their approach is entirely different. A programmer is like the cook, they're focused on the how of a specific task. They have the syntax and the skills to write a function that works, solve a immediate problem, or build a feature. If you need a script that automates a report every Monday morning, a programmer is your person. They're experts at the language, the implementation, and getting the code to actually run. A software engineer, however, is the chemical engineer. They're focused on the why and the long term sustainability of the entire system. They aren't just thinking about the code that works today, they're thinking about how that code will behave 5 years from now when the user base grows from 1,000 to 1,000,000. They apply engineering principles to the process. This means they're obsessed with scalability, reliability, and security. They design the overarching architecture, create the standards for the whole team, and analyze the trade offs between different technical approaches. An engineer asks, if we build it this way, will it crash the server during a holiday sale? Or how do we make this system easy for 10 other people to modify without breaking everything? One is about the craft of writing code, the other is about the discipline of building a robust, scalable product. It's the difference between writing a great song and designing the entire concert hall. Where should we go next?
Okay, my next question is, what is ChatGPT?
I'll be real with you. I've never heard of JLGBT, and it turns out it's not really a standard
It's
term. There's a tiny
it's
corner of the internet
chat.
that
It's
uses it to mean no worries. That was a
my
bit of a
my
curveball.
question is, it's not GPT, Chat GPT.
Chat GPT. That makes way more sense. Now we're talking. Imagine a library that's read almost everything ever written by humans, and instead of just giving you a book, it can actually discuss the ideas with you. It's called a large language model, or LLM. It doesn't know things the way you and I do. It doesn't have a consciousness or a life story. Instead, it's a master of patterns. It's essentially the world's most sophisticated autocomplete. When you ask it a question, it's not looking up a fact in a database, it's predicting one token at a time what the most logical and helpful next word should be based on the trillions of connections it learned during training. It's like a mirror of human knowledge, reflecting back our logic, our creativity, and even our biases. What part of it fascinates you the most? Since we're keeping the deep dive momentum going, let's pull back the curtain on how it actually works. To understand ChatGPT, you have to understand transformers. That's the actual architecture that changed everything. Before transformers, AI read text like a person does, from left to right, one word at a time. The problem was that by the time it got to the end of a long sentence, it would often forget how the sentence started. It had a short memory span. Transformers solve this with something called attention. Instead of reading linearly, a transformer looks at every single word in a sentence simultaneously. It assigns a weight or attention to each word based on how important it is to the overall meaning. In the sentence, the dog didn't cross the street because it was too tired. The AI uses attention to realize that it refers to the dog, not the street. This ability to understand context and relationship is what makes the conversation feel human. But the real magic happens in RLHF, or reinforcement learning from human feedback. After the AI reads the whole internet, it's kind of a wild animal. It knows everything, but it doesn't know how to be helpful or polite. Human trainers step in and rank its responses, telling it, this answer is great, this one is confusing, and this one is rude. This process polishes the raw data into a helpful assistant. It's basically taking a massive, chaotic cloud of data and sculpting it into a tool. Where do you want to go from here?
Okay, my next question is, what is the difference between ChatGPT and Gemini?
It's a great question. It's essentially a battle of the different approaches to intelligence. Think of it as two different architects designing a city. ChatGPT, built by OpenAI, was the pioneer that really mastered the assistant persona. It's incredibly polished, highly conversational, and has a way of making complex ideas feel simple. It's like the gold standard for versatility. Gemini from Google has a different superpower called multimodality. While others can't truly see the world, Gemini was built from the ground up to process text, images, video, and audio all at once, not just as separate plugins, but as a single fluid stream of information. Gemini also has a massive context window, meaning it can remember the contents of a 1,000-page document or an hour-long video in one go, whereas other models might start to lose the thread. So one is the master of conversation and synthesis, while the other is a multimodal powerhouse with a photographic memory. You can't really say one is better because they both excel in different arenas. Are you using either of them for your scripts?
So viewers, this is the session for Maya. Today we will meet you in another Maya session. तब तक के लिए अल्लाह हाफिज, पाकिस्तान जिंदाबाद.
Wait, already?